So now let's move to the third step, which is the entering of the flow data. Okay, so third step is to the third step is to enter the steady flow data. Steady flow data means we need to enter the value of discharge. Right? Suppose 2 lakh cubic of water, I am entering the value. So when this 2 lakh cubic of water enters into this cross section, then what will be the level of water at all the cross sections? That is computed by this software. Okay, so if we want to check this software or validate this software, then we can take the data of the downstream reach of Tapi river where Surat city is lying. Then we can by through that data we can plot this such type of cross sections, and we can enter that value of 8.9 lakh cubic, which was occurred in 2006 August. So when we enter that steady flow data value in this software, it will compute the water surface elevations, and that you can tally with the already existing values. So your software would get validated, and a number of research papers has been published using this software. So this software has been very well calibrated and validated. Okay. Sir, are you listening?
Yes.
Yes, ma'am. Yes, ma'am. You are audible.
Okay, okay, fine. Sure. So let's continue. Okay, so let's proceed with the third data. This all has been saved, so not to worry about that. Okay, so file, we go to edit. Now geometric data is done. We need to go for what? We need to go for steady flow data. It means કે આપણે discharge ની value અંદર નાખવાની છે, right? So description માં અહીંયા શું લખીશું? PF1 profile 1 profile number profile see in the second downstream column it is written enter or edit the number of profiles. 32,000 max. Number of profile means the number of discharge value. કે એકવાર નાખી 500 ની વેલ્યુ ને જોયું પછી એકવાર નાખી 1000 discharge meter cube per second ને જોયું પછી એકવાર 1500 ની વેલ્યુ નાખી. Okay, so you can enter 32,000 values of different discharge values. Right now here we are entering only one discharge value. So edit or enter number of profiles. We are going to enter only one discharge value. Here we are going to enter the value, suppose 250 meter cube per second. See at the bottom of the window it is written edit steady flow data for the profiles which is in meter cube per second. So here PF1 250, we are entering a discharge value of 250 for the cross section which we have generated. Okay, now we will go to the boundary conditions. So here, as I told you that we are working in a subcritical flow, we need to select the downstream boundary condition. Okay, for if we are working in a supercritical flow, that we need to select the upstream boundary condition. But here, as we are working in subcritical flow, it is by thumb rule that we need to go for the downstream boundary condition. Now here, as you can see, look at my cursor, 4 boundary conditions are given: known water surface elevation, critical depth, normal depth, rating curve. Okay, so we will go for the normal depth as it is mostly adopted. We will go for normal depth. When we click on the normal depth, a window will open which will ask us to enter the value of slope, right? We need to enter the slope value for the normal depth. So suppose I am giving a slope value of 0.0004. Okay, and we know that slope is unitless, feet by feet. So we are giving a slope of 0.0004. Now I will click on OK button. Okay. See here, normal depth as is equals to 0.0004 has been occurred. Okay. Now I'll go to OK button. Again OK. Okay. So reach boundary condition has been set. Profile value has been entered. Now what I will do, I will click on this apply button. Apply data, sorry. Okay, so here you can see the river Vishwamitri has came, reach 1, river station, all for all the river stations I am applying this value, so it will come for all the river stations. I don't want to change a flow location, so okay, this much is enough. Now this is done, we need to save this data. Steady flow data is done. I have entered the value of 250 meter cube per second of discharge. Okay, so we need to save this data. So go to file, save flow data as, okay, I will give a name of, suppose, okay, PF1 is fine. Profile 1. I'll click on the OK button. Okay. So this flow data, steady flow data has been saved. હવે આને ચેક કરવું હોય તો શું કરી શકો, સેવ થયા છે કે નહીં? Go on the main window. Okay. You can see this main window. So in main window steady flow માં આવી ગયું છે PF1, which is stored in the flood modeling folder and in our file of steady flow 1. Okay, PF1. So done. Now moving on the fourth step. હવે શું કરાવશું? આપણે calculation કરાવશું. Okay, so perform hydraulic calculations. આપણે discharge ની value નાખી દીધી, આપણે cross sections ની value enter કરી દીધી. We have done everything. Now we will what we can say, allow the computer to carry out the performance, that if we are entering the value of 250 meter cube per second of water, તો દરેક section પર water નું level કેટલું હશે. Okay, so let's just perform it. Okay, so this is saved. Now I will go to edit. Run. We need to now run the data. Okay, so we will run the which data out of all these? Steady flow analysis. We need to carry out steady flow analysis. So this window has been appeared. Okay, now here we need to give a name, plan name, and a short ID. For that we will go to file. We will select a new plan. We will give a title. See, new plan is the combination of a river and a reach. So which river are you selecting and which reach are you taking? You need to give a title for this. So I'll give it existing. Okay, downstream river reach 01. Okay. When I will click on this OK button, they will ask me for the short plan identifier, like a short ID for this plan. So I will write over here, reach 01. Okay, I will click on OK button. Okay, so now here you can see on the main window, plan downstream river reach has come, and which is stored in the flood modeling steady flow file P01, profile 1. Okay, we are done with all the calculations. We are done with everything. Now we have to run this data. So steady flow analysis, again we will go. We will check the plan name. We will check the short ID, geometry file, steady flow file. Our flow is which one? Subcritical flow, right? So our flow regime is subcritical. We will go on the compute button. We will press the compute button. Okay, so the process will start. See here, the computer is calculating, carrying out the process, and once it gets completed, you can get a stop close over here. See, look at my cursor, it is written complete process. So here the entire process is completed. You can close this window. Okay, now your fourth step is also done. which one that we have performed the hydraulic calculations. Now we have to just view the graphical results in we have to view the results in graphical as well as tabular form. Okay, so let's just go to view option. Okay, I'll first click on the cross section. See, which is our river station. This is our river station 1. And what is the level of water? This much. Okay, first before the cross section was empty. Now the water has been entered where the discharge value is 250 meter cube per second. Okay, if I'll go to the second cross section. Okay, so this is the second cross section. If I'll go to the third cross section, this is the third cross section, fourth cross section. So this is the fourth cross section. Okay, are you getting it? We have already successfully run the process and we are viewing the different cross sections. So here you can see that on the left bank canal, if I click over here, see, it is showing the values 227.05 and 73.48, right? So the elevation is 73.48 and the ground point is 227.05. But here you can see that in all the cross section, in every cross section, the water is inside the cross section only, right? It is not lying over this. If the level of water is above this ground point, suppose if it is lying up to this level, then you need to minus the elevation of this point. You need to calculate the elevation is of this point. You need to calculate the elevation of this point, and when you subtract these 2 points, this much amount of wall you need to construct. Are you getting what I'm trying to say? Okay, let me show you with the another example that I have. First of all, we will see this. So this, what we are computed this water surface profiles. That is the depth of water at different cross sections. Okay, so now you can go to the XYZ perspective plot. See, the discharge value is very less. It is only what we have entered. We have entered 250. Now suppose if I am entering the value of 3000 meter cube per second, then it could have much more than this. Okay, so this indicates the level of water, depth of water in the cross section. This is the 3D plot, right? Similarly, in the view option, you can also go for the detailed output tables. So what we have seen in graphical format, this is represented in the tabular format, like elevation, velocity, height, water surface elevation, total discharge, which is 250, right? Energy slope, which is in meter per meter. We have entered it in feet per feet. Velocity. So these are the details that we got in the tabular format. Now, what if we want to calculate, carry out into the word file? આ results ને કે આ ડેટા ને જો આપણે વર્ડ ફાઇલમાં લઈ જવા હોય, હવે આ ક્રોસ સેક્શન ને મારે વર્ડ ફાઇલમાં લઈ જવું છે, તો હું શું કરીશ? So for that I will go to file. I can directly print it also, or I can take it to this copy plot to clipboard. I will click on this option, copy plot to clipboard. So I will open a new word file, new Microsoft Word document. I will double click on this. Okay, and I paste it. I'll simply paste it. Okay, so this has been pasted to your word file. Okay, similarly you can also paste your detail output table. So this is a table. I will move to file. I will copy to clipboard. Both includes both data and headings. So this is copied, and here I will paste it. Okay, so this has been combed in this format, and you can make a table by giving columns and rows. So this way you can copy your results into the Word file. Okay, so here the webinar is completed, but wait, I'll show you some more projects which I have already stored. I will open another project. Yes, see, this is a very important point. Before going to close the project, you need to save this project, otherwise your project will not be saved. Your entire process will get what we can say, it will get not saved. So it is very necessary to click on the option button yes. So okay, this is saved. Now I'll open my another where I'll show you the XYZ perspective. This is the same one. Okay. See, this is the another plot. Now, if I take you to the cross sections of this cross section, here you can see. See, on the left hand side, this is the last ground point, and at the top here you can see the coordinates of this point. See, it is 109.96 and 88.53. Okay, so on the left hand side of the bank, the water is well within the section. So there is no overflowing of water. But if you see on the right hand side, there are three plots. See, this is the one plot. This is profile number 3, whose discharge value is, I guess, 1500. This is the profile number 2, whose discharge value is around 1000. And this is profile 3, whose discharge value is around 500. So for 500 and 1000 value of discharge, the water is not getting overflowed. The water is getting out of the bank, out of the ground point for this, which is a discharge of 1500. So here, if I can see, I can get the coordinates of this point, which is 271 and 77. So the elevation of this water at this cross section is 77. And the last ground point elevation is how much? It is at 71.50, and this was 77.50 and 71.50. Okay, so the last ground point is 71.50, and the water is coming up to the elevation of 77.50 for a discharge of 15,000 meter cube per second. So minus this 77.50 minus 71.50 will give us the value of 5.50 feet. So on the right hand side of the bank of the river, for a particular this cross section, you need to construct a flood wall. બરાબર, પાડ બાંધવાનો કેટલો કેટલો હાઈટ નો પાડ બાંધવાનો 5.50 ફીટ નો પાડ તમારે લેફ્ટ હેન્ડ સાઈડ પર બાંધવો પડશે ફોર પ્રોફાઇલ નંબર 3. પ્રોફાઇલ નંબર 2 અને પ્રોફાઇલ નંબર 1 એટલે ડિસ્ચાર્જ 2 અને ડિસ્ચાર્જ 1 તો સેક્શન ની અંદર જ છે, પણ ગ્રાઉન્ડ પોઈન્ટ ની બહાર કયો ડિસ્ચાર્જ જાય છે? પ્રોફાઇલ નંબર 3, which is almost 15,000 meter cube per second. So from this you can get the idea that yes, at this cross section on the left hand side of the river, you need to construct a wall, flood wall of 5.50 feet. Similarly, you can carry out for the other cross sections also. See, this is cross section number 2, this is cross section number 1. Oh, sorry, this is 4, this is 3, this is 2, this is 1. Okay, are you getting it? And we can also see the XYZ perspective plot. Okay, this is the rating curve. Okay, see, here you can see 3 profiles, 3 different profiles. So the first profile is, as I said, it is 500 meter cube per second of water. Second profile is 1000 meter cube per second of water. And the third profile you can see is of 1500 meter cube per second of water, which is flowing outside the river. So this much elevation you need to give flood wall up to this much elevation, here also up to this much, here also up to this much, and here also up to this much, in order to keep the river water within the river itself, so that it will not overflow and enter into the floodplain areas. And as I said, we were analyzing the one-dimensional flow. So we are dealing with the water surface elevations in the river itself. Okay. So here, this is the PPT which I can share with you afterwards. Okay, so here we are done with the webinar. Thank you very much for giving me this opportunity.